Hi everyone. Today we're going to look at recursive functions. Recursive functions are useful for describing sequences, and we'll start by looking at simple sequences where we're adding numbers on, and then we'll start to look at more complex ones in future screencasts. So let's get started. A sequence is an ordered set of related numbers 2, 4, 6, 8, 10. Could be 3, 6, 9, 12, could be anything really, as long as they're going up by a set series of numbers each time. A recursive function, though, rather than what we've done in the past with linear, just defines the next term in a sequence in relation to some other term. So we can predominantly do this two ways. We can define it in terms of the current term and the next term, or the current term and the previous term. Both of them will give us the same answer. The equations look very similar. But it changes the way you think about the recursion. So let's have a look at the first case. In the first case, we're going to define the current term as being term 1, which is this one here. And the next term is equal to the current term plus 2. So the next term, this one, is equal to the current term, this one, plus 2. And that looks like this. The next term, the current term, add 2, we're starting at 2. Quite simple. Now we can also define it in terms of the current term and the previous term. So again, we've defined the first term as 2, and we've still got we're defining this time, this one's going to be the current term. Let's write it on top here. But if the current term is 2 and we're defining it in terms of the one before it, this one now becomes the previous term. So this time, instead of saying the next term is equal to the current term, we're going to say the current term is equal to the previous term plus 2. And we define that as the current term, Tn, is equal to the previous term, Tn take 1 plus 2, where T1 equals 2. And this only makes sense now from n being greater than or equal to 2. And in this case, n would be greater than or equal to 0. No, 1, not 0. Nearly got it wrong. So T2 would be equal to T1 plus 2. Yeah, it doesn't have any meaning before 1. In the same way that this one doesn't have any meaning before n equals 2. So T2 is equal to T2 take 1, T1 plus 2. Yep, that works. Okay. So when we're trying to define a recursive equation, these things over here, it has two parts. The equation itself and the starting value. And without the starting value, this could describe a whole heap of sequences. So let's have a look at that quickly. Tn plus 1 equals Tn plus 2 could define 1, 3, 5, 7, 9, but similarly it could also define 2, 4, 6, 8, 10, or 5, 7, 9, 11 by adding a different starting value. So this describes a family of sequences. When we put the starting value on it, it defines a specific sequence. So if you're being asked to define a sequence, don't forget to put the starting value on. Now, many families of sequences can be defined using recursive functions. So let's go to one that we know quite well, being the Fibonacci sequence. And that goes 1 first, 1 second, and then add the two previous terms to get the next term. So 1 plus 1 gives us 2, 2 plus 1 gives us 3, 2 plus 3 gives us 5, so on and so forth. And we're going to try and define that recursively. So the first term is always 1. Well, in this case, I've called the first term T0. The next one would be 1 as well. And then the third one is n plus 2, 2 terms in front is equal to the previous term plus the term before it. Or the current term plus the one in front of that is equal to the term in front of that. Now, any way that you want to think about it that works for you is good. In this case, since we're starting with the first term being numbered position 0, n can be greater than or equal to 0. And we'll see if that makes sense for this equation here. So if n was 0 and we added 2 to it as according to the recursive function, that would give us t2 here, is equal to 0 plus 1, t1, which is 1 here, plus t0, which is 1 here. So we know that this way that t2 is equal to 2, as expected. t0, t1, t2. Then if we're working out t3, n becomes 1. 1 plus 2 becomes 3. That gives us our t3. 1 plus 1 becomes t2, which we know is 2. That goes here. Plus t1, which is 1, goes there. We now find that t3 equals 3. Beautiful. Similarly, when n is 2, 2 plus 2 becomes 4. 2 plus 1 becomes 3. And t2, so put t3 plus t2. That gives us these two values here. And we get 5, our t4 value. Now all that gets a little bit confusing, but we have our graphics calculator to the rescue. Let's see if it comes up nicely now like it's supposed to. Come on, graphics calculator, where are you? There it is. Oh, it doesn't like it in full screen mode. Oh, come back. Okay, so here I have my graphics calculator, and if I go down to sequence, which is down here, I've made a little slide to remind myself, I can set up a recursive function. Now in this case I've got it starting at 0, and I need in my equation an n plus 1 and an n, and I'm going to start at n plus 2. So find one that goes n plus 2 and starts at 0, so that'd be that one there. A0 is 1. A0, they're just talking about this value here. This value here. A1 is also 1. So that's this value here. Now I have to set the equation up itself. Click up here. We want a n plus 1, which is that one, plus a n, which is that one. I'm going to tick that to say that's the equation I want to work with. And I want the first 10 terms, so let's put 10 in here. And if I go OK and press the table button, lo and behold, actually I want to start at 0, don't I? That was a bit silly of me. Let's click back up here again. Don't start at 1, start at 0 or you'll miss the first value. Go. Right, now we get what we're expecting. So the sequence goes 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. Fibonacci sequence. Beautiful. Now that's not the only way that we can do it. We can also do it with spreadsheet mode. So let's have a quick look at that. Spreadsheet mode. Where's it gone? Maybe it's on the next page. No, definitely here somewhere. Oh, there it is. Let's clear this out. I'll just clear it out. And starting with the first value. So we start with 1. We have another 1. Now we're going to say equals A1, you can see it changed down here, plus B1. Oh, not A1 plus B1, it's going to be A1 plus A2. I'm not reading my own cells correctly. A1 plus A2. Now we should be able to say edit, fill down. Where's fill down gone? It's not there anymore. Okay, fill range. From A4 to A10. Let's see if that works. It hasn't quite worked, has it? Let's see what's gone wrong. No, it's just gone A1 plus A2 each time. Oh no, it started to do it properly, but afterwards for some odd reason. Let's go back to here and try it again. Edit, fill, range, from maybe if we go from A3 to A10. And go OK. And then we get the values that we expect. So you can do this either using sequences or with spreadsheet mode. Well, I hope that was helpful, and we'll be doing a few more of these in the not too distant future. Thank you, everyone.